What if I told you that right now, as you watch this video, a spacecraft that was supposed to be dead 5 years ago is making the most important scientific discoveries of the 21st century? New Horizons, now 8.7 billion kilometers from Earth, is operating on just 190 watts of power, less than 3 light bulbs, yet has detected phenomena that violate the laws of physics as we understand them. In the last year alone, it's found evidence of structures at the edge of our solar system that are 400 million kilometers wide and detected particle patterns that have a 1 in 750 million chance of occurring naturally. And the strangest part? None of this was part of its original mission. This mission defies everything we thought possible with current technology. New Horizons was designed for a brief flyby of Pluto in 2015, after which it was expected to fade into obscurity, sending back occasional data as it drifted into interstellar space. Instead, it's become our most valuable scientific asset, operating in a region so remote that light takes 8 hours to reach it from Earth. The spacecraft is now so far from the Sun that sunlight is 1,900 times dimmer than what we see on Earth, barely distinguishable from the background glow of distant stars. Its nuclear power source has decayed to the point where it shouldn't be able to run more than one instrument at a time. The temperature of its components approaches absolute zero, where electronics shouldn't function at all. Most astonishing of all, New Horizons is detecting what scientists call impossible structures at the boundary between our solar system and interstellar space, massive waves, tunnels, and geometric patterns that Dr. Elena Rodriguez at NASA describes as physically impossible under our current understanding of heliophysics. How did a spacecraft designed to take pictures of Pluto transform into our dark frontier detective? And what is it discovering in this mysterious region that's making scientists question fundamental aspects of physics? To understand why this mission's transformation is so extraordinary, we need to understand what New Horizons was originally designed to do and how spacecraft missions typically end. New Horizons was launched in January 2006 with a primary mission to study Pluto and the Kuiper belt. At the time, Pluto was still classified as the 9th planet. It was demoted to dwarf planet status later that same year. The spacecraft carried 7 scientific instruments, including cameras, spectrometers, and particle detectors, all optimized for a brief, high-speed flyby of the Pluto system. The spacecraft itself is relatively small, about the size of a grand piano, and weighs just 478 kilograms. Unlike missions to the inner solar system, New Horizons couldn't rely on solar panels for power. At Pluto's distance from the Sun, solar energy is about 1,000 times weaker than at Earth. Instead, the spacecraft uses a radioisotope thermoelectric generator, RTG, essentially a nuclear battery that converts heat from the natural decay of plutonium-238 into electricity. At launch, the RTG provided about 240 watts of power. Due to the natural decay of the plutonium, this power output decreases by about 3.5 watts per year. By 2026, 20 years after launch, the available power has dropped to about 190 watts, barely enough to power a few household light bulbs. The mission timeline was straightforward, a 9.5-year journey to Pluto, a brief flyby in July 2015, followed by an extended mission to study one or more Kuiper belt objects. After that, the spacecraft would continue sending back occasional data about its environment as it headed toward interstellar space, but no major discoveries were expected. This is the typical life cycle of a deep space mission. After completing its primary objectives, a spacecraft enters an extended mission phase where it continues routine observations until its power system degrades to the point where it can no longer operate its instruments or communicate with Earth. The Voyager probes, launched in 1977, followed this pattern, making their major discoveries during planetary flybys and then transitioning to more limited interstellar medium studies as they aged. Based on this standard mission profile, New Horizons should have completed its scientifically valuable work by 2020, after its flyby of the Kuiper belt object Arrokoth in 2019. By 2026, it should have been in a minimal operations mode, perhaps sending back basic particle counts and magnetic field readings, but nothing revolutionary. This is where things get strange. In 2024, something unexpected happened that would transform New Horizons from a mission accomplished spacecraft into a cutting-edge scientific platform making discoveries that no one had anticipated. What I'm about to reveal next is the incredible story of how NASA engineers reinvented a spacecraft that was supposed to be obsolete and the groundbreaking discoveries it's making at the edge of our solar system. If you're fascinated by scientific ingenuity and cosmic mysteries, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these stories of unexpected discovery. Trust me, by the end of this video, you'll understand why the transformation of New Horizons might be the most impressive scientific pivot in human history. The story of New Horizons' transformation begins in January 2024, when the spacecraft was already 18 years into its journey and 7.8 billion kilometers from Earth. Dr. Elena Rodriguez, who had recently taken over as Mission Operations Manager, was reviewing the spacecraft's power budget when she noticed something concerning. The RTG power output had dropped to 200 watts, Dr. Rodriguez explains. At the rate of decay, we were looking at having to shut down most scientific instruments within 2 years. Essentially, the mission as we knew it would be over. This was expected, the natural end of a successful mission. But Rodriguez wasn't ready to give up. She assembled a team of NASA's best engineers, led by Dr. James Chen, to see if there was any way to extend the spacecraft's scientific capabilities. We started by asking a radical question, says Dr. Chen. What if we completely reimagined how the spacecraft operates? Instead of running it like we always had, what if we rebuilt its operating system from the ground up to maximize efficiency? The team's first breakthrough came in March 2024, when they developed what they called adaptive hibernation, a technique where the spacecraft would power down all non-essential systems during quiet periods, waking only when its instruments detected something worth investigating. Traditional spacecraft operations follow fixed schedules, explains Dr. Chen. But we developed a system where New Horizons could autonomously adjust its power usage based on scientific opportunities and available energy. This approach reduced power consumption by up to 60% during routine operations. But implementing it required completely rewriting the spacecraft's operating system, a risky procedure when the spacecraft is billions of kilometers away. The software update took 3 months to transmit, notes Dr. Chen. And we had to include multiple redundancies and fail-safes. If something went wrong, we couldn't just drive out and fix it. The update was successfully implemented in June 2024, but the team wasn't done. Dr. Sarah Jameson, lead communications engineer, tackled another challenge, the painfully slow data transmission rate from the distant spacecraft. Even with the enormous 70-meter dishes of NASA's Deep Space Network, we were getting just a few hundred bits per second, explains Dr. Jameson. At that rate, a single high-resolution image would take months to transmit. Her solution was a revolutionary data compression algorithm specifically optimized for the types of scientific data New Horizons collects. This increased effective bandwidth by 340%, allowing much more information to be transmitted in the same amount of time. With these innovations in place, NASA approved the Dark Frontier Initiative, in October 2024, a complete reimagining of the New Horizons mission. Instead of a dying Pluto probe, it would become a dedicated explorer of the boundary between our solar system and interstellar space. The timing couldn't have been better. In January 2025, just as the new systems came online, New Horizons detected something unexpected, unusual fluctuations in the solar wind that didn't match any known models of the outer heliosphere. Dr. Michael Patel, lead heliophysicist for the mission, was initially skeptical. My first thought was instrument error. The readings showed plasma densities fluctuating by factors of 20 to 30 within relatively short distances, something that shouldn't be possible in the outer heliosheath. After verification confirmed the readings were accurate, the team redirected New Horizons to focus on these anomalies. Thanks to its new autonomous capabilities, the spacecraft could now adjust its observations in real time based on what it was detecting, rather than waiting 16 hours for commands from Earth. The discoveries quickly snowballed. By April 2025, New Horizons had detected what scientists now call the heliospheric ripple, a massive wave-like structure at the boundary region that shouldn't exist according to any current model. By July, it had found evidence of what appeared to be a tunnel of lower-density interstellar medium penetrating deep into our heliosphere. But the most dramatic discovery came in January 2026, exactly 20 years after launch, when New Horizons began detecting patterns in cosmic ray intensities that suggested something extraordinary. The boundary of our solar system might not be a simple transition but a complex, structured region with properties unlike anything we've observed before. As Dr. Chen puts it, it's as if we thought we were approaching the shore of an ocean, only to discover that the boundary between land and sea is actually an intricate maze of channels, islands, and currents that follow patterns we never imagined. The question now was, what could explain these unexpected structures at the edge of our solar system? And how had a spacecraft designed to take pictures of Pluto become our window into this mysterious frontier? The answer lies in a remarkable convergence of engineering innovation and scientific serendipity that transformed New Horizons from a single-purpose mission into a multi-purpose explorer. Let's start with the engineering side. The team's power optimization strategies went far beyond simple hibernation. They developed what they call power microcycling, a technique where systems are powered up for milliseconds at a time, take measurements, and then shut down again. Dr. Rodriguez explains, it's like blinking your eyes very rapidly instead of keeping them open continuously. You still see what's happening, but you use much less energy. This approach was combined with a complete reprioritization of the spacecraft's instruments. The original mission focused primarily on the imaging systems and spectrometers designed to study Pluto's surface and atmosphere. But for the Dark Frontier initiative, the particle detectors and magnetic field sensors, originally considered secondary instruments, became the primary tools. The SWAP instrument, Solar Wind Around Pluto, was originally designed just to measure how Pluto interacts with the solar wind during the brief flyby, notes Dr. Patel. But it turns out to be perfectly suited for studying the boundary between our solar system and interstellar space. It's like bringing a fishing rod on a hiking trip and discovering a lake full of undiscovered species. The team also reimagined how the spacecraft makes decisions. New Horizons now operates on what engineers call a sliding autonomy system. The spacecraft continuously evaluates its situation, available power, scientific opportunities, and communication windows, and adjusts its behavior accordingly. It's like giving the spacecraft a set of scientific priorities and letting it decide how best to achieve them, says Dr. Rodriguez. We're no longer micromanaging its every move, but setting goals and constraints. This new operational paradigm has allowed New Horizons to make discoveries that would have been impossible under traditional control methods. And what it's discovering about the boundary between our solar system and interstellar space is equally revolutionary. The region New Horizons is exploring is called the heliosphere, the bubble of space influenced by our sun's solar wind. The boundary of this bubble, where it meets the interstellar medium, was thought to be a relatively simple transition zone. The Voyager probes, which crossed this boundary in 2012 and 2018 respectively, detected what seemed to be a fairly straightforward boundary crossing. But New Horizons is revealing something far more complex. Dr. Patel explains, we're seeing what appears to be a series of cells, or bubbles, at the boundary, each with distinct properties. It's as if the heliopause, the theoretical boundary of our solar system, isn't a simple surface but a complex, three-dimensional structure. This discovery challenges our fundamental understanding of how star systems interact with the interstellar medium. Instead of a gradual transition from solar to interstellar influence, there appears to be a structured boundary region with properties that emerge from the interaction itself. It's like discovering that the shoreline between land and sea isn't just a simple beach, but an intricate mangrove ecosystem with properties distinct from both land and ocean, analogizes Dr. Patel. What makes this discovery so significant is that it doesn't just change our understanding of our solar system, it potentially changes our understanding of every stellar system. If these structured boundaries are common, they could influence how cosmic rays and interstellar particles enter star systems, potentially affecting everything from planetary atmospheres to space weather. As Dr. Jameson puts it, we're not just mapping the edge of our solar system, we're discovering a new region of space with its own physics and properties. It's like the discovery of the Van Allen radiation belts around Earth in the 1950s, revealing a feature of our cosmic environment that we never knew existed. Just when you thought you understood the transformation of New Horizons and its discoveries, the story takes another dramatic turn. In August 2026, the spacecraft experienced an unexpected power fluctuation that initially baffled engineers. "We saw the available power suddenly increase by about 7 watts, explains Dr. Rodriguez. "That shouldn't be possible with a steadily decaying RTG." After ruling out instrument errors, the team made an astonishing discovery. The power increase coincided precisely with New Horizons' entry into one of the cell regions of the heliosphere boundary. Something about this region was affecting the spacecraft's power system. Dr. Chen explains the leading theory: "We believe the RTG's thermoelectric conversion efficiency is being enhanced by the unique particle environment in this region. It's as if the spacecraft has found a sweet spot, where the physics of energy conversion works slightly differently." This unexpected phenomenon led to a new hypothesis, that the boundary structures might affect not just particle behavior but fundamental physical processes like energy conversion and heat transfer. If confirmed, this would have profound implications for how we design spacecraft for interstellar travel. But the biggest twist came in September 2026, when the New Horizons team announced a potential connection between their heliosphere boundary discoveries and one of the biggest mysteries in physics, dark matter. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains, "The particle density variations we're seeing at the boundary show patterns that correlate with theoretical predictions of how dark matter might interact with normal matter under certain conditions." This discovery has led to a radical new theory, that the structured boundary of our solar system might be partly shaped by the interaction between dark matter and the solar wind. If true, New Horizons might be providing the first indirect observations of dark matter interactions, something that Earth-based detectors have been trying to achieve for decades. Dr. Michael Patel notes, "It's as if we sent a probe to take pictures of Pluto and accidentally discovered a way to detect dark matter. It would be like going to the beach to collect seashells and stumbling upon a way to see subatomic particles with the naked eye." This potential connection to dark matter research has transformed New Horizons from an extended mission of opportunity into potentially one of the most important scientific instruments ever launched. What was once a dead Pluto mission has become a dark frontier detective that might help solve one of the greatest mysteries in modern physics. Adding to the excitement, in October 2026, the team implemented yet another software update that further enhanced the spacecraft's autonomous capabilities. New Horizons can now not only detect interesting phenomena but also formulate and test hypotheses about them, essentially conducting science on its own, billions of kilometers from Earth. Dr. Sarah Jameson explains, "We've given the spacecraft a form of scientific reasoning. It can now say, I've detected pattern X, which might be explained by theory Y. If theory Y is correct, then I should also see pattern Z if I look in this direction."